Welcome to another episode of Design for Advantage, our ongoing podcast series with Rafael, where we explore the systems and strategies shaping the modern battlefield. In previous episodes, we've looked at topics including precision strike, survivability, and air defense. Today, we're turning to intelligence and how it is evolving in an age of data saturation. Because on today's battlefield, the challenge is no longer just collecting information, it is making sense of it fast enough to act. How do modern forces turn data into decisions? And what does that mean for the future of intelligence? I'm Tony Skinner, Creative Director at Shephard Group, and joining me are Gideon Weiss, Rafael's VP of Business Development and Marketing, and Director Y from the Intelligence and C4ISR Systems Division at Rafael. Gentlemen, great to have you with us.
Hi, Tony. Great to be here again.
Hi, Tony. Great to be here.
So let's first of all start with the big picture. We often hear that today's battlefield is saturated with sensors and data across multiple domains. So I guess, is the real challenge now less about collecting and sharing information and more about the understanding of, what that information is telling you?
So I think intelligence challenges have fundamentally changed over the last few years, like in many other domains. And they shifted from the challenges of collecting any information, collecting data, collecting insights, to creating insights and to extraction of data into the actionable insights. And the other thing is that we see, especially in recent wars, both in between Ukraine and Russia, as well as in the Middle East, we see that the major challenge is for allied forces to work together. It means that they have multiple sources. They have to have some very specific processes for verification and validation, and they have to have very precise and clear insights for mission planning.
Okay, so as mentioned, Gidi, you know that the battlefield is drowning with data and information. It's not about just sharing this information, it's just sharing it in a processed manner, meaning that you're not just sharing the source itself, you want to have some kind of exploitation on it. You want to understand what you are sharing. And sharing technology is not the tough job that we have to do. Is first of all, capsulating and segmenting what we are willing to share, and otherwise making sure that the things that you are share are usable, but by your partners. Okay, we see that recent conflicts are not a single one-on-one conflicts. There are multiple nations involved, multiple scenarios, and multiple threats that needs to be handled. And I think one of the phrases that we were going to use in this conversation is, how do you industrialize this intelligence? How do you generate a pipeline that works on the fly and not just acting as ad hoc as things happen, and just processing it, having a pipeline, having some kind of manner to do it continuously, every day, every second, every minute.
Yeah, so when things go rampant and things go into the actual battle, then there are so many things to do, so many domains to cover in intelligence. So does it mean that we have to have a lot of just more and more intelligence agents, or how do we do the industrialization thing? That's the challenge.
First of all, I think that still is an ongoing challenge, but we have some solution in that area. One of the solutions is changing the way you think of intelligence, breaking these silos. In the past, we used to mention sensor fusion or things in that area that were more on the C2 level and a command and control system. But now, talking to intelligence, we're looking at things in a multi-domain, making some kind of insight, some kind of knowledge, generating knowledge from bits and pieces from different silos. In the past, you have some kind of signal intelligence. They were a silo. They didn't share anything, only the most processed products that they have. But today, understanding that if we can fuse and break these silos and working on a single plane where all the information is there, we can pick some fragments of this intelligence and generate real insights that we can push to the frontliners, which is very important because sometimes the HQ has everything, but nothing comes to the edge. And this is one of the challenges we need to go through.
Yeah, that's really interesting around the idea of moving away from sensor fusion, which I feel like, during my career as a defense journalist, a lot of the the ambition and the objectives was sort of moving towards that idea of sensor fusion. But yeah, I guess now it's all about multi-domain exploitation. I mean, you've touched on that in a little bit of detail, but from an operational standpoint, what are the benefits and advantages of what you're describing?
So first of all, sharing a database is something that is, let's say, technology supported, but it's humanly impossible for people to share the database.
Everybody's very protective. Everybody is very protective of their data.
Everyone wants to keep their own secrets. Okay, so sharing the database is something that is very difficult, but we do manage to generate a fused or multi-domain database that can take insights out of the several databases and bring it into the same playing field. Because today's adversaries, if you look at them, they are hiding, they are hidden, they try to minimize their footprint and their signatures. And only by looking at in a multi-domain manner, just not the image, maybe the signal intelligence, maybe some cyber information, maybe some human information, only by collecting all these things together, you can try to generate some cohesive enemy picture and understand what you are facing. So try to industrialize this effect is very difficult because, again, the time criticality of this information is a big challenge. If you know something is going to happen in 10 minutes, but you understand it only half an hour later, that intelligence is not worthwhile. So we need to have some kind of automation process.
Awesome. Yeah, I mean, that was a really interesting element when we're doing the preparation. The idea about the long game and the short game as being two distinct kind of operational challenges. I mean, Gideon, I don't know if you had any further thoughts around, how to overcome those distinct operational challenges.
Well, I think that strategically, when you look at how nations prepare, they need to understand their enemies in a political manner, militarily, tactically, but also operationally. So it's a strategic overview that needs to be departed between long-term and short-term. Long-term is always identify the big trends. What are they are interested in? What are their main challenges and what are they building up to over the years? And in the short term, it's what are they preparing for me tomorrow? What is their plan? What are they doing? And that's the challenge to understand between the long term and the short term.
So understanding the enemy's intent is fundamental in understanding whether, I'll give a few examples, whether it's an exercise or preparation for war. And these decisions.
Yeah, it's a great example.
These examples unfortunately, we have in the past misinterpreted the enemy's intent, and we thought they're doing some kind of exercise and a war broke. We have a few examples over the years in Israel that we had such wars. So really understanding the intent is critical.
And then when we talk about the short game and I guess, look at sort of real time ongoing operations, what are some of the biggest challenges that you're facing, when you're sort of under that sort of immediate pressure?
Well, I think it goes down to reaction time, right? It's about how quickly we can understand what's going on and put it into action. It's moving and placement of defenses. It could be a preemptive action, and it could be offensive operations that we need to prepare. So let's talk about that, right? How do we move it fast into action?
So it's all about automation. So we need to push the information fast, and we need to understand the speed and agility of this information to be distributed is fundamental. Okay, we need to shorten the timeline between first encountering some kind of sensor information and how we understand what is the intent of the enemy, what is the progress, where is he located, where is the enemy itself, and how we push it in real time and fast. This is one aim. And the second is generating a pipeline of targets for engagement, because you don't want to wait in the field, waiting for someone from somewhere giving you an understanding where is the enemy and what do you have to do.
Isn't that a problem of scale? If you're doing something right now, what do you do tomorrow? What do you do in the next hour, right? It's scale.
Yes, you need to manage thousands of enemy locations. thousands of targets to engage you. Your pipeline needs to be always full with the targets for engagement, with information, with intelligence. And also you need to build a plan, the operational plan. Looking at the past, information, we always used to say intelligence, if we'll have it is great. If not, we'll have to manage. But today's world, we cannot do it. We need to have it always there, always up to date, and always ready so we can exploit it and understand what the enemy is doing.
And I guess that idea around the tempo of operations, the pace of operations, the need for speed naturally brings us to the question of the use of artificial intelligence. We've gone halfway through the conversation and it's yet to come up, which is possibly a record. But I mean, there's obviously a lot of discussion around the use of AI in military operations and in defense operations. I mean, in practical terms, what's actually changing in the intelligence process, and, how is AI able to sort of create a better understanding of that intelligence picture?
Well, certainly AI is the next revolution in intelligence, and it is something many nations and a lot of organizations are already involved in. But in our view is that although we are years away, I really think we are years away from automation or maybe even creating robotics that can work AI in intelligence. AI is and must be a tool or as an agent. That's a must. Let's talk a little bit about that, how that is done here.
So looking at AI, we look at it in two different manners. One of which is using neural networks as an AI, the ability to understand what we are seeing, okay, and also trying to interpret what is within the image, looking at vast information. Just look at the Earth observation satellite.
That's on the side of machine learning?
Yeah, it's machine learning, and also sometimes it's even more deep than that, because you need to understand something that is not like machine learning. It's like, for example, if you like to look at occupancy, is a base inhabited? Is an airfield? Where are all the planes, for example? So this is one angle of the AI. The second one is the interface. We understand that LLM and chat GPTs and the clouds of these worlds are looking for facilitating a more natural approach, more human approach for asking questions. Sometimes software defining things is more difficult than just natural language, conversation, talking with the system, the AI, the agents within the AI. They can understand what you want from them and give you the required information you want, instead of trying to SQL or ask the question in a certain manner and actually it is some kind of code that they will understand.
You want to stay away from code and come back to whatever is more human intelligence conversation, right?
Yes, it's also very important in order to fasten the time that you train your analysts. Because if you have to train them on system operation, it's just the technicalities of how to use the system. You want to reduce this timeline also, because it's very hard to train analysts, to give them experience. And if you can shorten the time for the training, it's also very beneficial for armies. You reduce the load from people. You reduce also the bandwidth needed for people to understand and record, and what is the keystrokes, what is the right, what is the shortcut, and so on, and give it more of a natural feel to operate the system.
Right. I know that when we speak with decision makers, they are always preoccupied with the notion of how much staffing they need to put down, how many people they need to put and train, and how quickly they will be able to become trained and efficient in their job. Yeah, it's a great input. Okay.
And then, I mean, clearly the advantages of artificial intelligence, so in those sort of scenarios is really clear. And I guess it's easy to understand those immediate benefits. As analysts and operators become increasingly reliant on the use of AI, what are the safeguards around making sure that the data they're looking at the end of the day is trustworthy? What's the kind of the trade-off or balance here?
Look, intelligence and AI has to always be valid, tightly and connected to the real world. We know that AI has biases. It will always have biases. And we need to be able to live with those biases, but be able to correct them. So if we let those biases go rampant, if we let AI go unchecked, it will go rampant. It will make terrible mistakes in the combat field, and we need to be able to control that. So I think that's where we're coming, though. We can see that in simulations and war games, that when we let AI do whatever it wants to do, it goes rampant. There are huge mistakes, and therefore we need to keep it under check with the human factor. Now, I think there's a lot of room for us to discuss how that is done, right? That's a big question.
Yes, it's a big question. It's not just in intelligence, it's the usage of AI in everywhere, but we'll focus on intelligence. So building this trust between the man and the machine is based on two major things. One is the ability to reason. Let the machine explain why did it took some kind of decision, how did it came to a conclusion. This is one thing. And the other thing is the ability for the system to adapt in a dynamic manner that you can correct it. When you ramp up a system, usually at the beginning there will be more mistakes, but the system learns the user, learns the analyst. And once you correct it, it will have less false alarms, less things that you will need to correct it, and it will actually understand, if it makes sense, understand what is your intent and what exactly do you ask them when you seek some kind of information.
So what are we doing? Are we asking the machine to tell us what is the process of it making a decision, and that we can control that and correct that?
Yes, actually we ask the machine not just to tell us how did it come to this information, what are the sources, let them quote the sources, maybe link the sources themselves so that you can see the raw data if needed. But again, over time, the machine learns to actually give some kind of figure of merit to its decision. And as this machine is updated all the time and learning from experience what it did wrong, it will improve and you will have higher marks.
We are running out of time, but I really, for this one, really wanted to have that future focused question. If we were to project all this forward, what does the future of intelligence look like? And I guess from a human point of view, what excites you both about the art of the possible looking to the future?
Clearly, we're going to have more data. We're going to have more sensors. Everybody's going to have more sensors and better sensors. But everyone will need to be able to work with more international collaboration. That's key. If you are only able to work with your own intelligence and not be able to share it or utilize intelligence that's coming from international sources that are your allies in combat, you're going to lose a lot of time and a lot of very key intelligence that you can use for your benefit. So I guess I'm going to key this up to you. You need more AI agents. You need more power for your brain.
We need, the intelligence officers need more analysts, but they don't have them. So instead of analysts, they will have an agent. They will have an army of agents that will do the workflow they want them to do. They will do the dull work and just validate, bring it up for decision makers. What is the information? And you can, as an analyst, a senior analyst, instead of having junior analysts that are training and you need to validate them all the time, you'll have agents. You will have agents that will work 24/7 all the time, concentrate all the information you want interesting for you. Okay. And this is some of the key advantages in the future that we foresee. And of course, if we can use this platform for interoperability, because sometimes the questions asked by a certain intelligence analyst from a certain country is different than an analyst from a different country. But if they have some kind of partially shared database, think of the possibilities of asking a question instead of just on your own database, asking it on the intelligence database for a national partner that you have, someone in the field, someone that is more closer to the arena that you are now engaging. So the ability to ask them the same question instead of trying to explain to the person that you are working with, the co-intelligence officer that you're working with, exactly what you want is extremely difficult. But if you can question the database using AI, this will give an interoperability that is something that is futuristic.
So that idea of multinational interoperability has come up a couple of times over the course of the conversation. I guess I find it really curious that these technologies that we're talking about can be a potential solution for that kind of multinational interoperable challenge. So I guess, how is that going to evolve in the future?
Well, I think that there is an existing international collaboration example that is worthwhile mentioning. We call it crystal ball. This is actually the US White House coming with the Israeli cyber organization and the United Arab Emirates, coming together and forming what we call a crystal ball platform, which is a counter malware and
Counter ransomware initiative initiated through the White House. Yes.
And you think about what it means for organizations from different countries. We now have many, multiple international partners in Crystal Ball already sharing their information to be able to counter these ransomware attacks all over the world. How does it look like? How many partners do we already have in this?
So currently we have 44 partners from different countries. Sometimes bigger countries have more than one partner, different organization within that same country or state. But the ability to share cyber incidents in the ransomware domain is a good example of sharing intelligence, because sometimes intelligence is something that's preemptive, like we discussed in this conversation. But sometimes it's like, I've been attacked. I want to share with you so you won't be able to be attacked. So you can prepare yourself for something that is ongoing or coming your way. And the ability to generate trust, a multinational trust, is something that is actually remarkable. That was the key difficulty that we encountered in generating, but we have established such a mechanism for sharing intelligence in the cyber domain, in the ransomware domain.
So that's a really great example, that the use of that program Crystal Ball, to enable that multinational interoperability. Yeah, that's a really valid point. It's kind of been tradition on these podcasts to sort of end by asking you each, if there's one thing that you'd like defense leaders, listeners, decision makers out there to take away from this conversation, what would that one thing be? Gideon, I'll start with you.
I would say intelligence is no longer a peripheral. It's core, and it needs to be looked upon as something that is evolving, and it needs to have the international allied collaboration and interoperability to be able to make sure that every ally, every nation can not only defend itself, but can collaborate operationally with its allies. We see how important that is today in the recent events, especially in the Middle East.
I would say that my takeaway, or the things I would like defense leader to take from this conversation, is to think outside the box in a way that we need to have some kind of intelligence 4.0, like we have in the industry. How do we automate things? How we generate knowledge, which is cross-domain? Because it's very typical to have a lot of silos and they're not communicating. Generating a platform that enables sharing this information on a multi-domain.
Excellent. So that's all for this episode of Design for Advantage with Rafael. Today we explored how intelligence is evolving from a data collection challenge to a decision-making engine, and why speed, scale, and integration are becoming critical on the modern battlefields. My thanks to Gideon Weiss and Director Y for joining us. Gentlemen, thanks for your time.
Thank you.
It's been a pleasure.
A lot of fun.
And if you missed our earlier episodes, you can find them all at the Design for Advantage Content Hub at shepherdmedia.com. We'll put a link to that in the show notes. Until next time, thanks for listening.